So as I was walking around, I saw that a lot of you were able to make rectangles with your algebra tiles in order to solve problems 6 through 9, but you were struggling a bit with questions 10 and 11 because you couldn't make a rectangle. So today we're going to start a new tool to handle these equations that you can't complete the square or factor correctly. So this process is called completing the square. So to do so, we're going to look at a specific problem. In this case, we're using x squared plus 8x minus 2 equals 0. And this problem, similar to the problems that you're struggling with on 10 and 11, is not factorable. So we're going to look at some conditions that relate this problem to the problem you were working with. So some conditions for this completing the square method we're going to use. The first is that our a value has to equal 1. The second is that our b value is even. And that the third is that our equation has 2 real roots. So just for comparison, I'm going to write the standard quadratic form underneath our formula. So you can see that in our equation, the a value equals 1, the b value is even, and I plotted our graph, the y equals form, on Desmos here. And you can see that our graph has 2 real roots where it crosses the x-axis. So now that we know that we've met our conditions, we are going to start a process of completing the square using algebra tiles. So if we move over here, we have this area here that we're going to make the square on, and then any extra tiles we have we're going to place over here. So because we're using x squared, we know that we only need one x on each side of our square to get the 1x squared term in the middle. And we also know that we need 8 of these x tiles. So the x tiles, if you recall, go here and here. And since we have a square, we know that these 2 sides have to be equal. So we need to split our b value equally among these 2 sides. So to do that, we're going to put 4 on each side. So 8 divided by 2 gets you 4. So these are 1s. So we have 1 times x equals x. And then we have 4 more x over here. So total, we have 8x. So now for our c value, we are just going to put it off to the side for now. So over here, we have these -2 tiles, which is our c value. So now we're looking to complete this square. So we have to think about how many unit tiles we need to be in this square so that the square is completed. When we look on our sides over here, we have 4 tiles here and 4 unit tiles here. So this square here is going to have positive 16 unit tiles. But we don't want to adjust our original equation. So if we just added plus 16 to our original equation, we have a new equation. We want the total sum we're adding to be equal to 0. So if we're adding 16, we also need to have -16 tiles over here. So we're adding 16 and we're subtracting 16. So what does this look like in our actual equation? So we're going to move over here now. So let's write out our original equation. X squared plus 8x minus 2 equals 0. We're adding 16, so we'll write x squared plus 8x plus 16 minus 2, which was our c, and then we're also subtracting 16. So this 16 cancels this 16, and we're left with our original equation. So we get equals 0. So this portion of our new equation represents this square here. And this minus 2 and minus 16 represents this 18 here. So if we look at this square, we can see that when we were factoring before using rectangles, the total area of the square was equal to this side multiplied by this side. So we have x plus 4 on this side, x plus 4 on this side. So we have x plus 4 times x plus 4 minus 18 equals 0, or x plus 4 squared minus 18 equals 0. So this represents the total area that's represented by our algebra tiles. And we need that total area to be equal to 0. So because this is representative of negative 18 tiles here, we need to find an x value such that this is equal to 18, so that 18 minus 18 equals 0. So we have x plus 4 squared needs to be equal to 18. So if you remember from our algebraic computations before, this is the equation we're pretty familiar with. So I'm going to shift up here. So we have x plus 4 squared, we take the square root of both sides. So we get x plus 4 equals, when you take the square root, remember you get a positive and a negative root. So plus or minus the square root of 18. And then we subtract 4 from both sides. So you get x equals minus 4 plus or minus the square root of 18. So these are our roots. And if we go back over here, when we were trying to figure out the meaning behind this root that we got here, we see that in this equation that we're solving for, our y value is equal to 0. So we're looking for values of x that make our y value equal to 0. So if we pull up this new plot, it's plotted our roots that we just solved for when y equals 0, and they fall right on this x-axis here, because that's when y equals 0. So we've solved it for our equation that we were using. Now we're trying to see if we can solve it for a more general form. So let's go back to our ax squared plus bx plus c equals 0. So from our conditions, we know that a equals 1. And we're assuming that b is even, so we can divide it by 2. And we're assuming that it has 2 real roots. So we have x squared plus bx plus c equals 0. So going back to our algebra tiles, again, we know that we have just one x squared term, since our a is equal to 0. So you have x. We know b can be divided by 2. Just like up here, we needed these two sides to add up to 8. So in this case, we need this side and this side to add up to b. And we need it to be even because it's a square. So we're going to have b over 2 on this side and b over 2 on this side. So we have our x squared and just like before, we're going to put our c off to the side. So whatever our c value is, and we don't know how many tiles are in there right now. So again, completing the square, how many unit tiles do we need here? We have b over 2 on this side, b over 2 on this side. So we're going to need to add in b over 2 times b over 2, or b over 2 squared. And if we're adding in b over 2 square tiles, we better subtract b over 2 square tiles as well. So what does that look like for our equation? We have x squared plus bx plus b over 2 squared plus c minus b over 2 squared equals 0. And just as before, when we're multiplying a square, you're multiplying the two sides. So we have x plus b over 2 times x plus b over 2 plus c minus b over 2 squared equals 0, or x plus b over 2 squared plus c minus b over 2 squared equals 0. And once you get here, you can solve just like we did before to get your x roots where y is equal to 0.